In the previous lessons of this regular expression course, we have looked at character classes, negated character classes, flags, quantifiers, and a couple of other topics in regular expressions. In this lesson, we'll be looking at meta characters. In regular expressions, we have normal characters, which we have seen so far, like letters, digits, white spaces, and sometimes symbols. But we also have some types or kinds of characters, which are known as meta characters. And not just that, we also have kinds or types of characters, which are known as special characters. But don't worry, I have a separate lesson in this course where we'd look at special characters. Now, what are meta characters? Meta characters are characters in regular expressions which have special meanings. And now you may be confused because if you want to define special characters, it's also characters that have special meaning. So what's the difference between meta characters and special characters? Well, in the special characters lesson, we'll get to understand more about special characters, but let me give you a simple difference. In meta characters, it involves a combination of two characters, combination of a backward slash and a character. This can be backward slash B or backward slash S or a couple of meta characters which we'll look at in this lesson. But when it comes to special characters, they do not involve a backward slash. It's just a symbol. For example, a symbol like backward slash, a symbol like full stop, a symbol like the dollar sign, just a symbol that has a special meaning. So meta characters, combination of backward slash and another character, which as a combination has a special meaning, but for special characters, it's a symbol that has a special meaning. Again, we're going to learn more about special characters in the special characters lesson. So for meta characters, they have special meanings, like I said. These special meanings could be that they represent a group of other characters or they have a specific function in a regular expression. So what are the meta characters that we have in regular expressions? We have a couple of them, and I'll not be looking at all of them in this lesson because, again, like I mentioned from the beginning of this course, regular expressions can be a bit different for different languages. In this lesson, I'm going to talk about the common meta characters which you'd find in most programming languages or in most regex engines. The first one we'll be looking at is the white space meta character. This meta character, which is written as a backward slash and a lowercase s, matches a white space character. Remember that a white space is also a character as we have seen so far in this course. A white space can be a single space or a tab space or a new line, which is also called a line break. So let's see an example where we use this meta character in a regular expression. Take a look at the pattern on the screen. On the screen, we have the backward slash s, which is a white space meta character. Then we have a character class, which is A to Z. And after this character class, we have the quantifier with a fixed quantity of 3, which means the character class 3 times. So what we have here in this pattern is a white space followed by a character class of a range from A to Z, which is repeated 3 times with the quantifier 3 that we have. Now remember that the quantifier would be applied to the preceding character, which is the character class in this pattern. Now let's apply this pattern to a string like this. Let's say we have his $500 idea was, and then we have a line break, and then we have that bad. And for the pattern, we have the white space meta character. Then we have a character class of A to Z, which means A or B or C or D or E or F up until Z. And then we're going to repeat this character class 3 times using the quantifier of 3. Now here we have just one match, but let me turn on my global flag so that we can have all the matches in this string. I'm also going to put the case insensitive flag so we don't have to worry about cases. Now as you can see in the matches, even though we have the case insensitive flag I, this does not match HIS because the string is not preceded by a space. So here we have A to Z repeated 3 times. H is between A to Z, I is between A to Z, S is between A to Z, but this is not matched because our pattern also has this white space meta character at the beginning. But now when we look at space and IDE, which is a match, you can see here that the space comes from the white space meta character, I comes from the character class A to Z, D comes from the character class A to Z, E comes from the character class A to Z. repeated. So we have this character class repeated 3 times, and that's why we have IDE matched along with the space. Also, you can see that space and WAS is also matched. That's because we have a white space, then we have W coming from this character class, A coming from this character class repeated 2 times, S coming from this character class repeated 3 times. Another thing you notice here is that this line break is also matched, because you can see that this color goes from here to the next line. That is because white spaces also represents new line, which is vertical space. So you can see here that this vertical space, then THA, is also matched. And lastly, you can see that space BAD is also matched. Let's say I change this quantifier to 4. You can see our matches have reduced. Here we have space, then IDEA, which is the character class repeated 4 times. We have space again, which is the vertical space from S to T, and then we have THAT. And then this is no longer matched because our quantifier is now 4, but we only have 3 letters here. But I'm going to change this back to 3. So this is the white space meta character, which represents white spaces like your single space, tab space, or even your new line space. The second meta character we'll be looking at in this lesson is the non-white space meta character. This meta character, written as /uppercase S, matches a non-white space character. A non-white space character means matching any character that is not a white space character. Now, as we saw with the white space meta character, this is a meta character written as / and lowercase s, and as we saw, this matches white space characters. The non-white space character is written as / uppercase S, which matches non-white space characters, which means characters that are not white spaces. And this includes letters, digits, and symbols. This meta character can also be written as a negated character class containing a white space character. That is, you have the character class, then you have the caret, which means this is a negated character class, and then you have the white space meta character. So as we saw in negated character classes, this means match every other thing that is not a white space meta character, because that is what we have in our negated character class. If you haven't seen the lesson yet on negated character classes, I definitely recommend that you check it out. Now let's see how we can use this non-white space meta character in a regular expression. Let's say we have a pattern like / uppercase S with a quantifier of 4. This pattern means 4 characters together, which is not a space. So using our same string from the previous example, if I come here and I change this to / uppercase S, and then I have a quantifier of 4, you can see that $500 is matched. That is because dollars is a non-white space character, 5 is a non-white space character, 0 is a non-white space character, 0 is a non-white space character. If I put a space between the dollars and 500, you can see it is no longer matched, and that is because the white space is not a non-white space character. I don't know if you get what I mean. If we come here, you can see that idea is also matched. That is because IDEA is not a white space character, and here we have non-white space character repeated 4 times. You can see that THAT is also a match. So don't forget, a white space character is / lowercase s, which matches white space characters, and a non-white space meta character is / uppercase S, which matches every other thing that are not white spaces. Let's move on to the next meta character, which is the digit meta character. The digit meta character is written as / lowercase d, and this matches any digit character, which is your digits from 0 to 9. So instead of using a character class of a range of 0 to 9, you have your character class, you have 0 to 9, you can simply use the digit meta character. For example, let's say we have a pattern like this. You have a / d, and then you have a quantifier of 3. This means any digit once followed by another digit twice followed by another digit thrice. Our quantifier is 3, so that means a digit meta character repeated thrice. Now if we apply this pattern to a string like, let me clear this from our previous example, and we have a string like he has 22 cars, 345 houses, and 700 bottles. I don't know what he's doing with bottles, by the way. And then our pattern, like I said, is the / d, which is the digit meta character, and then we have our quantifier of 3. So as you can see here, 3, 4, 5 is matched. That is because 3 is a digit represented by the digit meta character, followed by 4, followed by 5, and this repetition, this 3 times repetition, is what we have in the quantifier here. You can see 700 is also a match. 22 is not a match because our repetition says 3, but we only have 2 digits here. But if I change the quantifier to 2, you can see 22 is matched, 34 is matched, and 70 is matched. But I'm going to change this back to 3. The next meta character we'll be looking at is the non-digit meta character. Just as we have an opposite for the white space meta character lowercase s, we also have an opposite for the digit meta character lowercase d. The non-digit meta character is written as /uppercase d, and as you may guess, this meta character matches any non-digit character. So this means it matches letters, spaces, and symbols. So instead of having to use a negated character class, like you have your negated character class, the square bracket, and the caret, which means this is a negated character class, and you have 0 to 9. So this negated character class means match any other character that is not between 0 to 9. So instead of having a negated character class like this, you can simply have the lowercase /d, which is the non-digit meta character. Now let's see how to use this in a regular expression. Let's say we have a pattern like /lowercase d, /uppercase d, and then we have a quantifier with a minimum repetition of 4 and a maximum repetition of 5. So this pattern matches a digit, this is a digit meta character lowercase d, followed by a non-digit, which is repeated for minimum 4 times and maximum 5 times. Now let's apply this to a string and see. So let's say we have a string like she has 5 cars, 6 bikes, and 7 bicycles. And like I said, with the pattern, we have the digit meta character lowercase d with backslash. Then we have a /uppercase d, which is the non-digit meta character. Then we have a quantifier with a minimum of 4, maximum of 5. Oh, you're not supposed to give a space. So as you can see in the matches here, 5 cars is matched. That is because 5 is the digit from the digit meta character, followed by cars, C-A-R-S. These are non-digits, and these are represented by the non-digit meta character. And because we have a quantifier with a minimum of 4, cars has a length of 4, and that is why it is matched. As you can see in the next match, 6 comes from the digit meta character, and then we have bikes, and these are all non-digit meta characters. And also here you can see 7 comes from the digit, BICYC are non-digits, and this comes from the non-digit meta character. So let's say I change these 5 cars to 54 cars. As you can see, 5 is no longer matched. It is now 4 cars because 4 is the digit and then cars is the non-digit. Even if I put a space between 4 and cars, you can see that this still matches because a white space is a non-digit character. And because we have the non-digit meta character, this would also match white spaces. It would also match letters. And like I said, it will match symbols. So even if I put 4 -cars, you can see that this still matches. So I hope you get the difference. Now with your digit meta character, it matches digits 0 to 9, and that is /lowercase d. With the non-digit meta character, it is /uppercase d, and it matches every other thing that are not digits, and every other thing that are not digits are letters, symbols, and white spaces. The next meta character we'll be looking at is the word meta character. This meta character is written as /lowercase w, and it matches any word character and an underscore. Your question may be, what are word characters? Word characters include letters and numbers. And word characters do not include symbols, but they only include an exception. So the only symbol that are included in word characters is the underscore. So white spaces and every other symbol are not word characters. Also, the letters can be in either uppercase or lowercase. It doesn't matter what case the letter is, it is still a word character. This meta character is an alternative to a character class containing letters in lower and upper cases and numbers and the underscore. For example, we have a character class like lowercase a to z, uppercase a to z, 0 to 9, then the underscore. So instead of having a character class like this, you can simply use the word meta character, which is the /, and lowercase w. Let's see how to use this meta character in a regular expression. So let's say we have a pattern like /, lowercase w, and then we have a quantifier quantifier with a minimum of 3 and a maximum of infinity, which means 3, nothing, then you close the quantifier. This pattern means any word character repeated 3 or more times. Let's apply this to a string example. Let's say we have a string like, she is the second fan of the Lofi musical. And then we have our pattern with the backward slash lowercase w repeated 3 times minimum or infinity, then we close the quantifier. Now, as you can see in the matches, she is matched because it contains 3 repetitions of word characters. S is a word character, H is a word character, and E is a word character. See, even if I remove the case insensitive flag, you can see that SHE is still matched. And that is why I said with word characters, the casing doesn't matter. A lowercase a is a word character, uppercase a is a word character. IS is not matched. That is because IS is just 2 and our quantifier says minimum of 3. So even if I is a word character, S is a word character, it doesn't match because our quantifier expects 3 repetitions at least. THE is a match. 2ND is a match. Remember, word characters include digits. So that means 2 is a word character, N is a word character, D is a word character. FAN is also a match. OF is not a match for the same reason as IS. THE is a match. LO_FI is a match. Remember, word characters includes the underscore symbol. And musical is also a match. So if I come to this LOFI and I change this underscore to hyphen, you can see it's no longer a match. That is because word characters do not include hyphens. Word characters do not include symbols. The only symbol that is included in word characters is the underscore. Just like white spaces and digits, word meta characters also have an opposite. So the next meta character we'll be looking at is the non-word meta character. And this is written as backward slash uppercase W, and this matches any character that is not a word character, which means it's going to match any character that is not a letter, a digit, or an underscore. So let's say we have a pattern like backward slash uppercase W, simple. And let's say we apply it to a string like $5 is a lot, and maybe we have a couple of spaces and then we have more. Then I have a new line than 1.50 underscore cents. Then I come here, I change this pattern to simply backward slash uppercase W. As you can see in the matches, we have all the spaces matched. The space between 5 and D is matched, between S and I, between S and A, here also, even the spaces here, even the line space, the vertical space, even the space between N and 1, the space between 1 and the and symbol, the space between the and symbol and 5, these are all matched because non-word characters include spaces. You can also see that the dollar sign here is matched. And do we have any other symbol? The underscore is not matched because the underscore is a word character. Let's say I add a quantifier of 3 to this. You can see the 3 spaces here matched, the 3 spaces here also matched, and we have this space and symbol space also matched because space and the and symbol or the ampersand are non-word characters, and these are represented by the non-word meta character. Another meta character we'll be looking at is the new line meta character. This character is written as backward slash lowercase n, and as the name implies, this matches new line characters. Let's say we have a pattern like backward slash n with a quantifier of 2. So this will match new lines that occur twice. Now let's say we have a string like what does that mean? Then we have a new line and then we have and then we have 2 new lines, then we have what are we going to do? And then we change this to backward slash n with a quantifier of 2. As you can see, the first line break between this question mark and is not matched. That is because we want 2 new lines. So you can see now that the 2 new lines we have, which is the one between and what, because this is a line break from here to here and from here to here, so that is 2 new lines. You can see that this is matched. Well, probably you're expecting that the new line meta character also has maybe an opposite, like backward slash uppercase n, but I'm sorry to tell you that at least at the moment that I'm aware of, there is no non-new line meta character. We only have the new line meta character, which is the /n. One more common meta character we'll be looking at is the word boundary meta character. But we'll not be looking at that meta character in this lesson. The reason for that is word boundary meta character can be a bit hard to grasp at first, so I thought of making this as a separate lesson. So after this lesson, the next lesson that comes after it in the course is going to be about the word boundary meta character, and you can trust me, I'm going to make it as simple as possible for you to understand. So the meta characters we've looked at in this lesson are the most common meta characters you'd find in regular expressions in many programming languages. Some programming languages or regex engines, like I mentioned earlier, may even have more meta characters than we have looked at, or maybe new ones may be added even after this course is published. So let's look at a recap of the meta characters that we looked at in this lesson. We have the white space meta character, which matches white spaces, the non-white space meta character, which is the opposite of white space meta character, and this matches non-white spaces. We have the digit meta character, which matches digits, and we have the opposite, which is the non-digit meta character, which matches non-digits. Then we have the word meta character, which matches word meta characters, and this includes letters, numbers, and the underscore symbol. And then we have non-word meta characters, which matches non-word characters like spaces and symbols, excluding the underscore. And then we have the new line meta character, which matches new lines. And then we have the word boundary meta character, which, like I said, we'll be looking at in the next lesson. You can use these characters in your patterns in diverse ways. You can use them with character classes. For example, you can have a character class, a negated character class, where you have /lowercase s and /lowercase w. And this is a negated character class which matches characters except a space and a word character. So in this case, this would match symbols because symbols are not word characters and they are not spaces. Another example is you can use meta characters with quantifiers. So you can have a meta character like /w, which is the word meta character, and then you have a quantifier like 5, and then you have another /lowercase d, which is the digit meta character. So this is a pattern which matches word characters repeated 5 times because we have a quantifier of 5, and this is also followed by a number. So word character, word character, word character, word character, word character, then a number. Now, as you would see in the rest of this lesson, we'll be using meta characters a lot, and we'll be using them in combination with other regular expression features. I hope this lesson was simple enough for you and you have a better understanding of meta characters now. Let me know in the comments if this was simple enough. But before we get to the next lesson, as usual, I have some assignments for you. For the first assignment, let's say we have this pattern which we want to use to validate the username that a user enters. In this pattern, we have a negated character class, we have a meta character, and we have a quantifier. Can you explain what this pattern means? Pause this video and try to figure out the interpretation before I share the answer. Okay, so in this pattern, we have a negated character class, and you can see that with the opening square bracket and a caret symbol. And in this negated character class, we have 3 characters. The first character is a digit meta character, which is made up of the / and the d. And then we have a caret character, and then we also have a question mark character. And after this negated character class, we have a quantifier which has a minimum of 5 and a maximum of 10, which means repeat this negated character class at least 5 times and at most 10 times. So if we had an example like user _ at Joe, this pattern would match because user _ at JOE, they are not in the negated character class. Also, a username like ++++ pass asterisk would also pass because all of these characters are not in the negated character class. And also a username like D and then space and then $code, this would also pass because all of these characters are not in the negated character class. But for passwords like the 100, my caret name, user $Joe, this would be invalid, and the reason is for the first invalid password you can see 100, 100. These are digits, and in our negated character class we have the digit meta character, which means the password shouldn't contain digits. For the second invalid password you can see the caret symbol there, and in our negated character class the caret symbol is not supposed to be present in the password. And for the third invalid password you can see we have a question mark symbol, and a question mark symbol is also in our negated character class. Now for the second assignment point, you'll be writing your own regular expression. Let's say we have a string like this. They sold 100 of their properties, chairs for $500, cups for $20, laptops for $3,500. Your assignment here is to write a pattern that would match $500, $20, and $3,500. And just to give you a tip, this is going to involve quantifiers and meta characters. Pause this video, head on to the REGEX 101 website and try to figure out a pattern that would solve this problem. So I believe you already attempted to do this and you got a right pattern, but let me just share my answer here. So we want to match $500, $20, $3,500, which means we want to match digits. Now I'm going to put the backward slash and D, which is the digit meta character. Now digits can be repeated one or more times. So I'm going to have 1, comma, and I won't put any maximum, which means the maximum is going to be infinity. So as you can see now, this is matching 100, 500, 20, 3,500. Even if I add more zeros to this 3,500, you can see it matches because we have infinity as our maximum. And then now I'm going to give a space and then I'm going to type dollars. So now you can see if I remove these dollars, you can see initially that this 100 was being matched, but what I want to match is the numbers for which dollars comes after. So now you can see $500 is a match, $20 is a match, $3,500 is a match. So I hope these assignments help you to understand meta characters better and shows you how you can use meta characters with quantifiers or with other characters in your regular expressions. Now let's move on to the next lesson where we learn about the word boundary meta character.